Welcome to the deep dive. Today we're really getting into the weeds, the mechanics of high-stakes AI. Specifically, how do we build knowledge assistants that actually understand you? Ones that don't get tripped up when a user and a document use different words for the same thing.
Yeah, our sources lay out a pretty clear path for engineers, for practitioners. It's this sophisticated strategy set they're calling knowledge RAG. We're looking for the shortcuts, really, the state-of-the-art ways to tackle semantic mismatch so you can move from, say, 50% accuracy up to that critical 90% you need for enterprise use. And, well, this whole issue comes into sharp focus with a classic example, one that probably feels painfully familiar if you've worked with these systems. The user asks their HR about a simple question. Do I get PTO as a part-time employee? Seems straightforward, right?
Sounds totally open and shut. The policy should just say yes or no, shouldn't it?
You'd think so. But then you look at the actual HR policy doc, the source of truth, and it says something like, part-time employees receive prorated annual leave. Now, for a human, that connection is instant. PTO, annual leave, same thing. And prorated clearly links to part-time. But here's the problem. Standard AI systems, especially those relying purely on semantic embeddings, often just fail here. Embeddings are good at general similarity. They might know employee is close to staff, but they frequently miss that exact crucial semantic link. PTO and prorated annual leave. Lexically, they're worlds apart.
Oh, okay.
So you can't just expect vector similarity to magically understand jargon or acronyms or even common synonyms. That's the gap. That's the engineering challenge we really have to tackle.
Okay, let's unpack that failure then. If that simple connection gets missed, what's the actual consequence in a big system? What's the real-world cost, right now in 2025?
Well, the sources are pretty blunt about this. It's not just a minor glitch. They call it an accuracy imperative. These semantic mismatches, like missing that PTO link, they slash retrieval recall by a huge margin. We're talking 30% to 50% in production R8 systems.
Wow, 30 to 50%.
Yeah, it means potentially half the knowledge you've carefully indexed might be invisible if the user doesn't phrase their question just so.
Missing half the answers just because of a different word. I mean, that's catastrophic if you're using this for customer support or legal research or anything important. It just obliterates user trust, doesn't it?
It absolutely does.
Yeah.
And that's precisely why the industry is moving so fast towards more layered solutions. The data shows that putting in effective hybrid fixes can push that recall number back up, often to 85% or even higher.
Okay, so there are fixes.
Definitely. And for serious enterprise-level stuff, query rewriting isn't really optional anymore. These 2025 evaluations, they're showing that query rewriting just on its own can cut down on system hallucinations, the AI making things up by around 40%.
40% fewer fabrications just by rephrasing the input. That's massive.
It's huge. That kind of reliability is simply non-negotiable for high-trust applications.
Okay, so if the standard vector embeddings are, frankly, dropping the ball this badly, what does the right architecture actually look like? What are the core principles, maybe the three non-negotiables we have to build into a R pipeline to hit that 85% plus recall?
Right. It's definitely about layers.
Yeah.
No single technique is a silver bullet. So the first pillar, absolutely foundational, is hybrid retrieval fusion. You simply cannot rely only on semantic vectors. You've got to blend that intent-based search with good old keyword search, typically using sparse vector methods like BM25.
So hold on, BM25, if we're talking advanced AI, why bring back keyword searching tech that's, well, decades old? Seems a bit backward, no.
It feels counterintuitive, I get that,
Yeah.
but it's absolutely necessary because of how these systems fail. Semantic search is great for general meaning, the overall intent, but it's often terrible with specific things, product codes, acronyms, legal citations, even a term like BM25 itself. Hybrid fusion covers both bases. If a user asks about policy section 7.2, the keyword search nails that exact term, while the semantic search grabs the surrounding context and meaning. Blending them consistently boosts recall, often by 20 to 40%, especially in documents dense with jargon.
I see. So you search for what the user meant and also precisely what the user typed. You catch the intent and the specifics.
Exactly. That's the idea. Now, the second pillar is query expansion or multi-query generation. We know users won't use the exact same phrasing as the documents, right? So we anticipate that failure. We use an LLM before retrieval to rephrase the user's original query, generating synonyms, different angles, different ways of asking. So instead of searching just once with the user's input, you might generate, say, 3 to 5 slightly different, highly specific variants. For a PTO example, maybe it generates prorated vacation eligibility and annual paid time off for non-full-time staff. Then you search with all of them. It's like an ensemble approach. This proactively bridges those lexical gaps.
That definitely sounds powerful for catching variations, but doesn't that add latency? Running an LLM prompt just to start the search process.
That's a key consideration, absolutely. It's a trade-off. We'll touch on caching later to mitigate it, but for high-value queries where accuracy is paramount, that extra latency step is often well worth it for the accuracy gain.
Okay.
And that brings us to the third essential pillar, re-ranking for precision. After you've done your broad search with hybrid fusion and maybe query expansion, you'll likely have a larger set of potential documents, some maybe a bit noisy. So the next step is to use a more sophisticated model, often a heavier cross-encoder or specialized LLM, just to reorder those results. This re-ranking step doesn't find new information. Its job is to look closely at the documents you already retrieved and push the absolute best, most relevant ones to the top. It acts like a quality filter, significantly improving the precision of your top results, maybe by around 25%, cutting out the noise that slipped through the initial net.
Got it. So start broad and inclusive with hybrid. Diversify the search with query expansion, then sharpen the focus and confirm quality with re-ranking. That sounds like a solid, multi-layered defense. Now, this is where it gets really interesting for me. Moving into those advanced enterprise-grade systems, the Q3 2025 focus, what are the specific cutting-edge techniques really making a difference on the toughest semantic gaps?
Yeah, this is where we move from principles to specific tools. A big one is query rewriting in practice, but taken a step further. It's using a generative LLM not just to create synonyms, but to actually clarify and, well, de-jargonize complex user inputs. Imagine a user types something messy, maybe multiple questions tangled together, like info on benefits if I quit versus getting fired. The LLM's job is to take that ambiguous input and rewrite it into a clean, search-friendly, precise query. Something like comparison of severance packages and vested 401k benefits for voluntary resignation versus involuntary termination. That refined query hits the vector database much more effectively.
Right, so you're basically shifting the hard work of interpretation from the search index onto the LLM upfront. Maximizes the chance of a good hit right away.
Precisely. Then there's a really clever, maybe slightly more out there technique called HIDE, which stands for Hypothetical Document Embeddings. This is wild. It doesn't just rephrase the user's query. It asks the LLM to generate a whole fake document, a hypothetical ideal answer based on the query.
Wait, it makes up an answer that doesn't even exist yet. Why would you do that?
It sounds weird, but it's a smart search strategy. Instead of searching the vector DB using the embedding of the user's short, possibly vague query, you search using the embedding of this longer, well-structured hypothetical answer. The thinking is that the embedding of a perfect answer often sits much closer in the vector space to the real correct documents than the original query did. It's a neat way to handle more abstract or high-level questions where the query itself might not be a great match for any specific document chunk.
That's fascinating. It's like describing the ideal answer you wish existed and then searching for documents that look like that description.
Exactly. It tackles abstraction really well. Now, looking at the really emerging stuff, the Q3 2025 breakthroughs, we see a few key trends. First, fine-tuned embeddings. This is huge. Companies are taking base embedding models and training them further specifically on their own domain data, their documents, their terminology.
Custom training.
Yes. This is critical for linking internal jargon or very specialized terms, like ensuring the system knows that in this hospital's context, myocardial infarction is the exact same thing as heart attack. You bake that domain knowledge right into the embeddings.
You're basically customizing the AI's vocabulary for its specific job.
You got it. Second trend, more sophisticated fusion retrieval. This isn't just basic hybrid search. It's running multiple different retrievers, maybe several dense vector models, a keyword model, maybe even a graph-based one all at once. Then merging their results intelligently using methods like reciprocal rank fusion. The goal is maximum coverage, pulling the best from every angle without getting redundant results. And finally, probably the most advanced thing we're seeing is agentic query transformation. Think of this as multi-query on steroids. An AI agent doesn't just generate variants once and stop. It runs an initial query, looks at the results, and if they're poor, it automatically refines and reformulates the query based on that feedback, then tries again. It can iteratively navigate complex, multi-step semantic problems. Wow. Okay. And the sources back this up with real-world results, right? These aren't just lab experiments. Can you share some of those case study impacts? Absolutely. That HR policy example we started with, the one stuck at maybe 40% accuracy. The sources say that implementing query expansion and hybrid methods pushed accuracy up to 92%. That's transformative. It goes from being an unreliable gadget to an essential tool.
Huge difference.
Or think about legal document search. A massive headache is shifting terminology. Maybe you search contract termination, but the key document only ever says agreement dissolution. By integrating domain-specific dictionaries and fine-tuned embeddings trained on legal language, one system reportedly cut those kinds of synonym-related misses by 60%.
60% reduction in missed documents in a field like legal. The risk reduction there is enormous.
It really is.
Right.
Similarly, in healthcare, with all its acronyms, using fine-tuned embeddings, specifically trained to link things like EMR firmly to electronic medical records, showed significant recall improvements in pilot studies. These advanced, tailored techniques are what make knowledge RAG work reliably at scale.
Okay, so we've covered the accuracy gains, but moving beyond the techniques themselves, how do you manage all this complexity at scale? If you're running LLMs to rewrite queries, doing ensemble searches, how do you keep it stable, reliable, and reasonably fast for the listener who needs to deploy this?
Great question. Scale demands discipline and the right tooling. The first piece is rigorous evaluation loops. Standard metrics like precision and recall aren't quite enough when you have generative components. You need RG-specific metrics like those in the RGA's framework.
Or JS metrics, right? How do those help here, specifically with these more complex pipelines?
So RGAS gives you metrics like faithfulness, does the generated answer actually stick to the facts found in the retrieved documents? And context relevance, where the documents retrieved actually relevant to the user's question in the first place. You need to test your system constantly using these metrics, especially on test sets specifically designed with tricky synonyms and variations. The goal is to iterate until you're hitting 90% or more on these dimensions in production. Second, to tackle the latency issue you raised earlier, caching semantic variance becomes really important. If the LLM expands PTO query into 5 variants, and that leads to the right answer, you store that mapping. The next time someone asks us a similar PTO question, you reuse the cached expansion and maybe even the cached response. This drastically cuts latency. The sources mentioned 2-3x improvements in high-volume situations. You pay the LLM cost once for common stuff.
Ah, smart. Use the expensive step judiciously, then cache the result for speed and consistency on repeat questions. Ties performance to reliability.
Exactly. And finally, because language evolves, new regulations pop up, product names change, slang shifts, continuous dictionary updates are vital. You need feedback loops, maybe using user interaction logs or identifying common failure patterns to constantly refine your synonym lists, your domain dictionaries, your acronym mappings. This keeps the system from becoming stale. And threading through all of this, the sources consistently give one piece of pro tip advice. Always fuse semantics with keywords. Hybrid R is king. Relying only on semantic similarity will cause you to miss specific acronyms, codes, and edge cases that keyword search just handles reliably. Never go pure semantic.
Okay, so wrapping this up, what's the big picture takeaway for you, the knowledge engineer or AI practitioner listening in?
It seems crystal clear. Getting to truly high accuracy and knowledge retrieval isn't just about chasing the next slightly better embedding model. It's much more about smart engineering around those embeddings. It's about acknowledging the inherent limits of semantic similarity alone and deliberately building these layered systems, the hybrid search, the query transformations, the re-ranking specifically to handle the messy reality of human language.
That layered approach really is non-negotiable now. Hybrid RAG, definitely incorporating query transformation, possibly agentic methods for complex cases, using ensemble techniques. That's the dominant, proven strategy for dealing with the real-world query diversity we see in Q3 2025. It's the necessary defense against semantic confusion, against lexical gaps. So, here's the final thought, something for you to chew on this week. Just how robust is your current RAG system to simple linguistic variation? The sources suggest a practical test. Take your top 10 most frequent user queries. Now, rewrite each one using 3 different, maybe tricky synonyms or acronyms for key terms. Run those variations through your existing pipeline. If your system stalls on more than 1 or 2 of those variations, well, the data strongly suggests you'll see a significant immediate payoff from implementing query rewriting or expansion and then rigorously tracking those recall improvements. It seems like the fastest path towards that crucial 90% plus accuracy score.